Welcome, children. In today's session, we will see conditions for solving pair of linear equations in two variables. Uh, in our previous class, we learned how to solve pair of linear equation graphically. Okay, now today here we will see the second method of solving, that is algebraic method of solving pair of linear equation. But before going to that algebraic method, first we must learn, or we shall learn, the conditions for solving pair of linear equations. Okay, so these conditions will help us beforehand uh, beforehand applying this algebraic method. Or we can say, if I know the condition, then it will be easy for us to solve any pair of linear equation in two variable algebraically. Okay, so let's see the condition first, and then we will go for algebraic method. So as I told you, today in this video we shall learn conditions for solvability of pair of linear equations. So solvability means uh, solving, finding solution. So conditions for finding solution of pair of linear equation. So here we will learn the conditions. What are the conditions uh, which which can help us beforehand applying algebraic method. So let's start now. Let us assume the general form of pair of linear equation. Let the general form of pair of linear equations in two variables b. The same thing I will use, is a1x b1y plus c1 is equal to 0. So I'll mark it equation 1. So in our previous discussion also we have represented general form by this expression, and the second equation, a2x b2y plus c2 is equal to 0. And here we know what are this equation 1 and 2, because we've already dealt with this kind of expression or equation in previous class or previous classes. So let this be the general form of pair of linear equation in two variable. Then now before whatever we did in our previous classes, that is graphical method, so here this is different because here we are going to learn algebraic method. So here we will not use graph to find solution. So instead of using graph, we will make use of certain method to find the values of x and y algebraically. Okay, but before using those method, if I know the condition will help you or help me a lot. So because we have seen in that graphical method three graphs we found, three types of graphs we learned: intersecting, where we get one answer, that is okay; coinciding, where x and y uh, have infinite values; and then one more was there where the lines were parallel. So lines were parallel means the answer of the values of x and y does not exist, means we cannot find out the values of x and y. So that is the problem uh, for us. If we get a parallel line, you will never get answer. So in algebraical or algebraic method, you cannot draw graph. So without graph, it is difficult for us to find or to tell whether the equation will have solution or not. That's why this condition will help you to understand this thing. Okay, so these are the thing. Then we can write here then the above pair of equations may have, so I'll write all those three cases here. Those three cases will come. First case, first condition, this is the first condition. So let me use this, we call unique solution. Already we discussed about this. Okay, unique solution in the graphical method where lines are intersecting. So unique solution. So how will you know algebraically whether this equation will have unique solution or not? So for that we have one condition, that is the thing what we are going to learn in this topic today. So for unique condition, you must have this one, a1 divided by a2, b1 divided by b2, and this two should not be equal. If these two are not equal, then we call this as unique solution. I'll tell you, I'll explain this thing. a1, a2, b1, b2, these are the ratios of the coefficients of x and y. If you see here, x in both the equation, the coefficient of x is or are a1 and a2, and similarly the coefficient of y are b1 and b2. So what I did, I just took the ratio of this a1, a2 and b1, b2. So if the ratio is not equal, then we call, or we can say, the equation has unique solution, or equations have unique solution. Why? Because this condition is there. Okay, so without using graph, without graph and using this condition, I can tell, if I find this condition, then I can tell the given equations will have unique solution. Okay, so this is the first condition. So now quickly I'll write here only. This unique solution was also we discussed there only. Such unique solution is also known as consistent equations. Means such equations, when such equation have unique solution, then such equations are called consistent. So I will write here only, the equations are consistent. Okay, so don't get confused. In our previous classes we discussed about this consistent word. Okay, so unique, consistent, this we should keep in mind, both are same. And if you talk about the graph, if you remember, let me draw here. If this is our axis system, x and y, then the nature of lines in such case is, we know it is intersecting. We discussed earlier, we already did this kind of thing. So let me draw here one line and the other line. Okay, so let me draw here. So see, these two are intersecting at one point. So the lines are called intersecting line. Consistent. The lines are intersecting. Okay, they're intersecting at one point. So these three things we must remember: unique solution, which is also called consistent, and if we talk on the basis of graph, we call intersecting line, or lines are intersecting. Okay, so this is the first case. Now let's go for the second case. In second case, now I think you understood the thing. The second one, it was no solution. If you remember, it was no solution. No solutions. No solutions. Okay, so the condition for this: a1 by a2, b1 by b2, c1 by c2. Now this third one is also added, c1 and c2. Okay, this all I'm taking, a1 a2, b1 b2, c1 c2. So this first ratio will be equal, a1 a2 b1 b2 will be equal, and the third one will not be equal. So if I get this condition in that pair of equation, then I can say that equation will have no solution. Means you will never get the values of this x and y. Okay, x and y, you will never get the values of these two. So that's why we call no solution. And this also we discussed earlier. So this case we call such equations, the equations are called inconsistent. Okay, this was the term we use in graphical method. And if you see the graph, now easily you can make out. Now I think you already understood that nature of graph. There only we discussed. In such case, what we get parallel lines, right? We get parallel lines. So these are this type of thing we get. So you will get parallel lines here. Okay, this earlier was intersecting, now this is parallel. So I can write here, the lines are parallel. No? So this is on the basis of graph. So usually we use these three three different terms for the same thing. Like for unique solution case, either we can use consistent or intersecting lines. In case of no solution case, either we can use no solution, inconsistent, or parallel line. Okay, so this is how we can tell if I get this condition, first two ratio equal and the third ratio is not equal, then we can say no solution. So without using graph, we can tell that the equation will have no solution and we don't need to solve it, because see this condition if I get, I can easily tell that equations will have no solution and I don't need to solve it. Okay, third number. Third is we call infinite many solutions, or infinitely many solutions. Okay, the meaning is same only. Now this is, for this the condition is a1 a2 b1 b2 c1 c2, all the ratios must be equal, then only we call infinite many solution. Okay, so if I have all these three ratio equal, then I can easily tell the equation will have infinite many solution, and again I don't need to solve. So if we see here, we call, if you remember, such equations are also called consistent equation. Okay, and if you remember the nature of graph, it was if you remember, the nature of graph was coinciding, meaning overlapping. In one single line, means one line is enough to represent both equation, right? So this is coincident. So I can write here the lines are coinciding. The lines are coinciding or coincident line. Coinciding or coincident line. Coincident lines. Okay. So these are the three conditions which we need before using any algebraic method. Okay, so if I know these three conditions well in advance, then I don't need to solve at all. Okay, so without solving, I can tell whether the equation will have unique solution, no solution, or infinite many solution. And the best part of this method is that these conditions are that good part, we can say the good thing is that if I get this condition unique solution, then only I need to solve it using your algebraic method, because algebraic methods are comparatively little lengthier in compared to graphical method. Okay, graphical method you just need to plot the graph and you'll get the solution, but in algebraic method you need to solve algebraically. Okay, so comparatively it is little lengthier. So if I know these three conditions beforehand, then I can easily tell, I can easily what called I am ascertain that the equation will have a solution or not. Okay, so in case, let me tell again, in case of unique solution, if I get this condition, then only I need to solve, I need to apply algebraic method. Otherwise, in case of no solution condition and infinite many solution condition, we don't need to solve, because in these two cases, in this case you will never get answer, so you don't need to solve, you don't need to apply algebraic method. And in this case you will find infinite values, so this is also we don't need to solve. Okay, so only for unique solution case, consistent unique solution or intersecting line, in this case only we need to solve a pair of linear equation using algebraic method. Okay, so these are the three things, three conditions we learned now. Now let's see some example on this three. So I kept questions here. This is the question. I kept here one question. So the question on comparing the ratios A1, A2, just now we discussed A1, A2, B1, B2 and C1, C2, find out whether the lines intersecting the following pairs of linear equations whether the lines representing the following pairs of linear equations intersect at a point, means intersecting line, unique solution, are parallel, we discussed earlier, and coincident. So okay, all three conditions I kept here, and let's try to find out here, let's try to learn it out. Okay, so how to use those three conditions. So equations are kept, 1, 2, 3 equations. So let's see solution. In number 1 we have 2x plus 3y plus 5 equal to 0. This is my equation 1, and second part of this equation number 1 is this equal to 0, second equation. Okay, I wrote both the equation. Now let's compare. Here a1 by a2, we know what is a1, a2. So a1, a2 are nothing but the coefficients of this 2x, x in equation 1 and equation 2. The upper one is a1, listen carefully, see, upper one is a1, and the coefficient of second x, this lower one, is a2. So 2 3. So when you take this ratio, then when we substitute this value, remember you should write number along with the sign. Okay, so here 2 is positive, 3 is also positive, so I can write 2 by 3. Done. Next, b1 b2. One more thing you should remember in writing this ratio. When we write the ratio, if number are such that we can cancel them, you should go for cancellation and write the simplest form. Okay, 2 and 3 are co-prime here, so if you find any composite number here, then you should divide it, cancel it, and get the co-prime. So b1 b2. So b1, if you see, these are nothing but the coefficient of y. So first y is 3, second y here is 7 with minus sign, minus 7. So 3y minus 7. So it is 3 by minus 7. Okay, done. You cannot cancel. 3 and 7 are co-prime. Now if you compare a1 and a1 ratio, a ratio and b ratio, what do we find? A1 by a2 is 2 by 3, and b1 by b2 is 3 by 7, minus 7. So do you think these two ratios are same? No, they are not same. If they are not same, you don't need to find c1 by c2. Okay, in case when a1 a2 b1 b2 are found to be same, equal, then only you should go for c1 c2. So here these two are not equal, so I don't need c1 c2. So I can conclude here. Okay, I can conclude a1 by a2, b1 by b2. Are they equal here? So we can easily tell they are not equal. So they are not equal. So this is what I get. So what was this condition? If you remember, let me show you again. A1 by A2, B1 by B2 is nothing but unique solution. That means consistent or lines are intersecting line. So in this question, what they want us to do? To check whether lines are intersect at a point. See, intersect at a point, are parallel or coincident. Okay, so this is unique solution since this I'm using this one, this condition tells me that these equations have unique solution since the given equations have unique solution. Therefore the lines are equation intersect at a point. Okay, so I can write the pair of lines, the given pair of lines are intersecting, or lines, or pair of, not lines actually, pairs of equations, the given pairs of equations intersect at a point. Intersect at a point. So question, it was told find out whether the lines are intersecting or not. So say intersect at a point. So we found the condition was for, this was for unique solution. So unique solution means intersecting, so lines are intersecting. So this how I can easily conclude that this equation have this equation will intersect each other. If I plot the graph, I'll find intersecting line. Okay, so this is what the question was asking. So I don't need to go further because here only I got the thing what they wanted us to find out. Okay, so number one done. Number two, equation 2 is 5x minus 3y plus 2 equal to 0, and 10x minus 6y plus 4 equal to 0. This is equation 1 and equation 2. Okay, equation 1 2 we got. So let's find out a1 a2. Here a1 a2 is, see, it's 5 by 10, no? 5 by 10. So 5 by 10, these are composite, they are not co-prime, so this will cancel. 5 1 5, 5 2 1 by 2. Get b1 b2 as well. So it is, see, minus 3 and minus 6, 3 and minus 3 and minus 3, minus 6, minus 3 by minus 6. Sign also we should take, minus will get cancelled and again you'll get 1 by 2. So a1 a2 1 by 2, b1 b2 1 by 2, both are same. So if both are same, I should go for third also. So third one is c1 c2. What is that? 2 by 4. 2 divided by 4. Again we can cancel 1 by 2. So what we find? a1 a2 1 by 2, b1 b2 1 by 2, c1 c2 1 by, all are equal. Okay, even sign, everything should be even if values are same, and if your sign somewhere is different, plus or minus, then we cannot say same. Okay, like this. If I have 3 by 2, 3 by 2, and here if I have minus 3 by 2, see, these two are same, but this third one carries minus, so this will not be equal. Okay, so take care of sign as well. So this is not required. Okay. So here we find everything is same, so I can write since a1 a2 is equal to b1 b2, okay, and equal to c1 c2, all are equal, all are equal. So I can write, therefore, so this, when all three are equal, if you remember the condition, when all three are equal, a1 a2 b1 b2 c1 c2, if all are equal, what we call infinite many solution, consistent or coincident. No? Lines are coinciding or coincident line. So in this question they were asking intersect, see, intersect at a point parallel or coincident. So here we find this particular condition, a1 a2 b1 b2 c1 c2 all are equal, so we can call lines are coincident. So therefore directly I can write the given pairs of linear equations are coincident. Okay, so we got this what called second also. Now let's go for third equation. Third equation you can easily make out. Let me try third equation. So let me do here third equation. Third number equation is 7x plus 2y. We have 7x plus 2y plus 6 equal to 0, and 21 6 18, 21x 6y 18 equal to 0, and sign are plus and minus, plus minus. Okay, so this is the equation third number. So I'll mark equation 1, equation 2. Okay, now let's go for this. Here now you can easily make out, I think you got the concept. Here a1 by a2, 7 by 21, 7 by 21, we can cancel them. 7 1 time, 7 3 time. b1 by b2, this is, see, y2 y6, 2 by 6, again I can cancel. Then c1 c2, 6, and this is minus 18. Okay, sign 6 minus 18, this is 1 by 3 with minus sign. Now we find here 1 by 3 is equal to 1 by 3, but this is not equal to 1 by minus 3. So I can write since a1 by a2, this condition is very important to write, b2 is not equal to c1 by c2. Okay, this condition is very important to write here. So this was the case of, we can see here, a1 a2 b1 b2 are equal, but c1 c2 are not equal. So in such case we call no solution. That means inconsistent and lines are parallel. Okay, lines are parallel. So here what we got in third equation is a1 a2 equal to b1 b2, but it's not equal to c1 c2. So this is parallel. So this will give parallel line. So I can write, therefore the given pair of equations gives parallel lines, or equations, you can write directly, equations are parallel. Okay, so this this is how we apply those conditions what we learned today. Okay, so the condition, once you know how to use the condition, this is how we learn here. So this will help you uh, to solve pair of linear equations by algebraic method. Okay, so this is what we did today, the condition what we learned today, that is the condition of solving pair of linear equation. So now I'm sure you're familiar with the condition, how to apply the condition. So this condition will help you to find out the solution algebraically. Okay, so that we will see in our next class. So try to understand this, go thoroughly. It's very simple, it's not that difficult to understand. Only three conditions we need. So if you know these three conditions, it will help you a lot in our next what call topic, that is algebraic method of solving pair of linear equation. So this will help there. Okay, and we need to see some more question, means there are questions that we get based on these three conditions that we will see in our next class. Okay, so I will wind up here today. This much for the today, this much for today. So we will see some more example on these three conditions in our next class. Okay, yeah.